When we're growing up, we tend to be pretty credulous. We just believe almost anything that people tell us, especially authorities and adults and textbooks and politicians and television, YouTube, the internet. I mean, there's just this sort of sea of information coming at us. And how can you tell the difference between, it's right or it's wrong? How do you know? People believe weird things because our brains are wired up to find meaningful patterns. You think if you see the face in the cloud or the face on Mars or the Virgin Mary in a grilled cheese sandwich or on the side of a window, many patterns are real, and it's good to know what those patterns are, and that's called learning. We connect A to B, and often A really is connected to B. Problem is, a lot of patterns are false. They're superstitious thinking. They aren't real. Well, I'm often asked when I give talks, why should we believe you skeptics? And my answer is, you shouldn't. You shouldn't believe anybody based on authority or whatever position they might have. You should check it out yourself. And we call this generally our baloney detection kit, sort of inspired by Carl Sagan's idea that there's a lot of baloney out there and we need a kit to detect it. And that kit is called science, and that's what science does best. So the first of our baloney detection questions you should always ask when you hear somebody make a claim is, how reliable is the source of the claim? You do expect some errors to creep into data, of course, but the errors should be scattershot. They're random. This way, this way, this way, this way. The errors are here and there, and they kind of cancel each other out. If the errors are all in one direction, slanting toward a particular belief, then that makes us suspicious that there's something else going on. Like the global warming skeptics, for example, will often pick and choose data that always slants toward that particular belief, or their errors always slant toward skepticism about global warming. And that tells us there's something else going on there. So a second question to ask is, does the source often make similar type claims? For example, New Age people, the people that believe in spirituality and ghosts and haunted houses and UFOs and all this, they believe the whole thing. They tend to be more susceptible to magical thinking, or maybe they're heretics just for the sake of heresy. Rather than following the data to see if that is a heretical idea that's going to overturn the mainstream, maybe. Usually that doesn't happen, though. The point here is you want to have a mind open enough to accept radical new ideas, but not so open that your brains fall out. So the third point in our baloney detection kit is, have the claims been verified by somebody else? You make a bold claim, somebody else has to be able to go out and test it. So the classic case study on this is 1989 cold fusion claim. Pons and Fleischmann hold a press conference. They announce, look, we can produce fusion in a jar on a desktop. This will solve our energy crisis. This will be energy too cheap to meter. This will change the world. Everybody was all excited. It was in the headlines, front page news, the whole thing. Until people went out and tried to replicate their experiment, and nobody could do it. So that told us right away, okay, there's something else going on here. It's a byproduct or an artifact. It's a chemical reaction. It's something other than what they claimed it was. So when you make a claim, if you don't have the data that other people can then go to their labs and run the experiment just like you did, if they can't get the same results, there's something wrong there. And in science, we require that. So our fourth point in our baloney detection kit is to ask, does this really fit with the way the world works? When you get one of those emails about the Nigerian, inheritance of $20 million, if you'll just send your money to them and then they'll send you the big pile of money, really, come on. Is that really the way the world works? I mean, a pile of money for nothing? Probably not. For example, in archaeology, we often hear about, the pyramids, the mystery of the pyramids. Who built the pyramids? The Egyptians built them. Oh, no, they couldn't have built them, because, wow, they're incredibly complex and so on. Well, it's just a pile of rocks, right? I mean, they had a lot of free time, a lot of cheap labor, never rains, centuries to build these big pile of rocks. Come on, it's not that complicated. But even if it were true that somebody else built the pyramid, say maybe 20,000 years ago, this is one theory. Maybe the lost continent of Atlantis and the Atlanteans came over there and built the pyramids. If that were true, when you do the archaeological dig, you should find the tools, the trash, the junk of the people who lived there, the houses where they lived, and that is what you find, dated at the time of the Egyptians. So if it was the aliens or the Atlanteans or whatever, you would find other artifacts to support that. So our fifth question you always want to ask, has anyone tried to falsify this or disprove the claim? In other words, it's one thing to pile up a bunch of evidence, go, look, I have this radical new idea. Here's my arguments in support of it. Okay, interesting. But what are the counter arguments? Have you thought about that? Have you thought, what else could be explaining this? Because if you don't do it, somebody else will, usually with great glee, in a published public forum. You really have to kind of think about what your critics would say, not because you care about your critics, but because they may find something you're not thinking of. So you got to think along those lines. Try to disprove your claim. So our sixth point in our baloney detection kit is to ask where the preponderance of evidence points to, this theory or some other theory. Anybody can make a claim and then pile up a few points in favor of it. The question is what about all the other evidence? Is it also leaning toward this, or is it leaning toward that other theory that you're trying to challenge? So at all times, like in the theory of evolution, for example, creationists will say, well, just, what about this one little thing here? Well, okay, maybe there's a few gaps or we can't explain this or that. But what about the 10,000 other pieces of evidence that are explained by the theory of evolution? How would you explain those with your other theory? In a way, science is a little bit like solving a crime. The guy never confesses, right? So you have to piece together the evidence that's available. And is it this guy or is it that guy, or did this happen or that happen? And the way criminologists work is they try to kind of look at the massive data and go, you know what? It's all kind of pointing that guy did it. And let's see if we can build our case. And that's a little bit how scientists work. There's always other ideas. The question is, what's the one that the preponderance of evidence points to? So our seventh point is to ask, are the people making the claim playing by the rules of science? That is, are they using the logic and reason and empirical evidence and testing and corroboration and so forth? Or are they just trying to make a case for their particular claim? So for example, a nice case study is the difference between UFO proponents and the members of the SETI community, the Search for Extraterrestrial Intelligence. They both are interested in aliens, but there's a radical difference in the two communities. The one community, the UFO people, they tend to not be scientists. They have no training in science. They don't do experiments. They're not trying to disprove their claim by looking for other explanations. And yet the SETI people, by contrast, they're looking for ways to disconfirm their idea. They're running experiments. They're testing their hypotheses. They're trained professional scientists. So even though they both have the same interest, or there are aliens out there, they come at it at radically different perspectives. And that's why one we call science, SETI, and the other one we call pseudoscience, ufology. So the eighth point in our baloney detection kit is to ask if the claimant is providing a positive evidence in favor of their theory or just denying evidence for the other theory. That is, it's one thing to compile a list of problems with the other guy's theory. So you have to actually have positive evidence in favor of your contrary or heretical theory. So, for example, you often see the UFO people say, well, we don't, I'll ask them, where's the evidence? Where's the UFO? Where's the alien body? Well, they covered it up. They've hidden it. It's hidden in Area 51, or they buried the bodies in Roswell, or, they're at some Air Force base. Okay, that's just negative evidence. That's saying, I don't have positive evidence. All I can say is that they concealed the evidence. Okay, that doesn't count. I'm sorry. They'll often hold up these government documents with big blocked out type and go, look at that. The fact that something is covered up for some national security military reason, that doesn't mean it's extraterrestrial. There may be a terrestrial reason for that. So when Bigfoot people, they say, well, Bigfoot's out there. Okay, maybe, there could be a bipedal primate running around in Canada somewhere. Show me the body. Oh, well, the bodies, they hide and they're very secretive and there aren't that many of them and so on. Maybe, but look, you want to name a new species of biology, you got to give us a type specimen. An actual body that we can dissect and look at, you can look at, and I can look at, photograph, put it in a museum, take it to the lab, and so on. It's not enough to have negative evidence against the other theory. You got to have positive evidence in favor of your theory. So on our ninth question in the baloney detection kit is, does the new theory account for as many phenomena as the old theory? Anybody can find a few anomalies that the current prevailing theory doesn't seem to account for. In other words, in science, it's okay to say, I don't know, you have a few anomalies, a few mysteries, and so on. But what pseudoscientists tend to do is they tend to take those few handful of mysteries and say, well, that's my whole new theory. At Skeptic Magazine, we always get these long, single-space type manuscripts of a theory of everything. And it always starts off, Newton was wrong, and Einstein was wrong, and Stephen Hawking is wrong. But I have worked out this new theory of physics that explains the world. But the question is, can this new theory explain all the other things that Newtonian gravity explains, and Einstein's global general relativity explains, and quantum physics explains? If they explain one little thing, that's really meaningless unless they can explain all the other stuff that's currently explained. So the 10th question we should always ask in our baloney detection kit is, do the personal beliefs and ideologies and worldview of the person making the claim, is that what's driving their research, or is it the other way around? In other words, science and everything else it's done by people, and people have biases. Confirmation bias, we look for and find confirmatory evidence for what we already believe, and we ignore the disconfirmatory evidence. This is a classic case. So, for example, we did a whole issue of Skeptic Magazine on global warming, and I had a left-wing scientist and a right-wing scientist and a scientist with no wings at all. And, why would there be scientists with wings, political leanings? Well, because they're people, and they vote. And something like global warming, well, you can see by just listening to talk radio and so on, this is very ideologically driven, where people, say, well, if I'm pro-business, I have to be skeptical of global warming. Wait, how about just following the data? Shouldn't the data tell us whether the Earth is getting warmer or not? Well, it is. And shouldn't we be able to discern from the data whether the global warming is caused by human activity or not? Yes, we can, and it appears that it is. So what's all this politics stuff? Well, because we're people. So in science, at some point, you have to remove politics and ideology and say, what is the data? What the baloney detection kit does there with our little 10 questions is it helps us, when we encounter a claim, think about it in different ways. What you're going to find is that there's a range. Some are just obviously bogus. The Earth is flat. No, it's not. It's round. The Earth is going around the sun, not vice versa. Yes, okay. There's things that we know for sure are true. Evolution happens to be one of those. Maybe global warming is sort of leaning toward that now, but it's taken a while. And there's other things like maybe some radical new theories about the cosmos, whether there's multiple universes out there. Well, that's sort of more in the uncertain range. And then there's things that are almost surely not true, like, psychic telepathy, where I can read your mind, that sort of thing. Those are surely not true. So you get this range of probably true to probably not true. Science is the best tool ever devised for understanding how the world works. And everybody knows that because they all go to doctors. And if somebody's flying at 30,000 feet in a plane, they're not skeptical of math and engineering. They know this is the best design possible, and so on. So most of us, when we're playing with our iPods or we're using our Google search engine and we're on the internet and we're watching our high-def televisions and so on, we love science. We know science works. And we know the basis of it is sound and all that stuff. It only comes to a few things, like when it comes to, what's the meaning of life, or where did we come from? What is it, what does it all mean? What's the future? There we start to think, well, maybe I should be skeptical of science. In fact, really, science is the best thing ever devised for understanding the world. We should love it.